How are you, my friends? This is Basic Math Terms, Part 17 about long division. The terms that are coming in this video are dividend, divisor, quotient, remainder, long division, synthetic division, what is a zero, types of zeros, rational zeros of polynomials, and Descartes' rule of sines. Please, you can check the playlist, Basic Math Terms, for other parts. So we are still in the algebra course, terms, and it will take from part 1 to part 18. Then we will move to pre-calculus course. When we divide numbers, this is 92 as a simple example, divided by 5. So we call 92 the dividend. This is the number we are dividing. Divisor is the 5. 92 divided by 5. See, 9 divided by 5 is 1. This is easy to do. Then when we get 18 here, 18 we call it quotient. This is the result of dividing. So dividend divided by the divisor, we will get quotient, and whatever left here, at the end you get 42 minus 40, you get the number 2. We call it remainder. So we can write 92 divided by 5 as a simple equation here. See, 92 divided by 5 is 18. That's the answer, the quotient, plus whatever in the remainder, 2 divided by 5. This is one way we can write the answer. Or if you multiply by 5 on both sides, see what we'll get here. 92 is equal to 5, the divisor, times the quotient, plus only the remainder. So 5 times 18 plus 2 is 92. We will take more complicated example in 1 minute here. Remember this 92, it was 5 times 18 plus 2 from the previous slide. You can divide polynomials now, more complicated expressions. Dividend still equals the divisor, see this one here, the 5, times the quotient Q of x, divisor is D of x, and you can call dividend P of x, plus the remainder R of x. Remember, D of x cannot be 0. We cannot divide by 0. Now here you can write this as this one, P of x divided by D of x is equal to Q of x plus R of x, the remainder divided by D of x. This is a nice example using long division to divide a polynomial 6x cubed minus 19x squared plus 16x minus 4 by x minus 2. The same method we can use for dividing numbers, but it's more difficult. See here, you can divide the term with the highest power, 6x cubed divided by x, you get 6x squared. Okay, so easily you can do that. And then you multiply back. See, the long division, you divide first, then you multiply 6x squared times all this, you get 6x cubed minus 12x squared. Then you subtract, you have to put a minus, as we did in the 92 divided by 5. You combine only like terms. So this will be cancelled. There's a minus and minus, that's plus 12x squared. And there is a minus 19x squared, so it becomes minus 7x squared. Then we continue, bring down 16x minus 4. Then you proceed. You can see more questions in lecture number 36 of the complete algebra course. Here we are explaining only the terms. So this is a long, we say long, that means the steps are too many steps to divide. There's another way called synthetic. We will see it in a few minutes. So quotient here is what we get in the answer, and the remainder, whatever left. It can be 0, it can be a number, it can be x, it can be anything. This is synthetic division. It's a simple and quick way of dividing. But there is one condition. The divisor, the one we are dividing by, should be of the form x minus c, like this one here. You see x minus 3. So it cannot be x squared or x cubed. So take this polynomial here, 2x cubed minus 5x squared plus 3x minus 10. Use only coefficients. We have seen the word coefficient. These are the 2 minus 5. Here you see 3 and minus 10. So this is the method. We use only coefficients. And then here x minus 3, put it equal to 0. We get x equals 3. So we put it here on this corner. So you bring 2 down, then you multiply. You see in the red, you multiply 2 times 3, you put it back here, then you add. So the number goes down. So this is the 2 goes down. Multiply in the red here, you multiply, then you add. And then you continue the process. 1 times the 3, put it there, then you add. 6 times the 3, 18, then you add. So this is the quotient, the first 3 numbers. It will be the coefficients only, 2x squared plus x plus 6. The remainder is the last number. So this method here, short and quick, easy way, we call it synthetic division, but the divisor should be x minus c or x plus. It can be x minus 3. So here we put it on this corner, we put 3. If we have x plus 4, we put here minus 4. Zeros, we have seen this slide before. The zero of a polynomial function, if you replace that number c in the function, it will give you 0. So to find the zeros, you put p of x is equal to 0. Here on this right side, very simple, easy example. 2x minus 6, this is a function. When you draw it, it's a line. If I say find, if I say find a 0, put f of x is equal to 0, 2x minus 6 is equal to 0, x is equal to 3. So the 0 will be 3 and 0 for the y. Zeros can be complex or real. Now, rational zeros test, or we call it rational zeros theorem, is a very powerful method of finding rational zeros. Rational zeros like the number 2, 3, minus 1, half, 2 over 7, 1 over 18, 10 minus 60, all these are rational zeros of polynomial functions. So we can use this method if we cannot factor the function. Look at this function here, p of x, 2x to the power 4, etc. This is very complicated. And this one is more complicated, x to the power 5 minus 3x to the power 4. We cannot factor these to find the zeros, because the important thing is to find the zeros. From there, we can find real zeros. And from there, we can find x-intercept, and then we can graph it. So if we cannot factor, we go to rational zeros test. You can see this for more examples in lecture number 37 of the complete algebra course. Descartes' rule of signs. This is another rule here. It will help you to determine the number of positive and the number of negative real zeros. How many? Like you have 2 positives, 3 negatives, 1 positive, 1 negative, no positive real zeros, only the number. Remember, not the real zero, the number. How many positives, how many negative zeros we have. Also, it will be in lecture number 37 of the complete algebra course. I will put on the next slide here one example from that lecture. Determine the different possibilities for the number of positive and negative zeros of this function, x to the power 4 minus 6x cubed plus 8x squared plus 2x minus 1. Here we have degree 4. That means there are 4 zeros total. Now, to find the number of positive real zeros and the number of negative real zeros, using Descartes' rule of sign, we have to look at the coefficients here, positive and then negative here. See, the positive, I will put a red mark, and the negative, I'll put a black one here. So positive and negative, there is one change in the signs, and this is a minus and plus, there is no change. So function has, the f of x has 3 variations. So we say 3 or 1 positive zeros. This is according to Descartes' rule of signs. You have to subtract 2. So if you have 5, it will be 5 variations here, 5 or 3 or 1. If you have 4 variations, you have 4 or 2 or 0. Always you have to subtract 2. Now, if you put x here, replace it by minus x, you simplify the whole function. Every x you put minus x. So you'll get plus x power 4 plus 6x cubed plus 8x squared minus 2x minus 1. Clearly here you can see only these are 3 positives and these are 2 negatives. So there is one change only from positive to negative. One variation or one change means 1 negative zeros. If you find the zeros of this function, which this function has 4 zeros, one of them is negative for sure. Maybe 3 positive, maybe 1 positive. So you can make a table here, nice and easy. Put all the possibilities. So if you have 3 positive and you have 1 negative for sure, real zero, then you have no complex. 0 is the number of complex zeros. Because remember, total zeros are 4. If you have a positive 1 here, 3 or 1, if you have 1, then 1 negative, that means in that case, you have 2 complex zeros. So these are the possibilities. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.